Good evening, class. We are looking at college algebra practice test number 3, module 3, covering chapters 5 and 6. Chapter 5, polynomial and rational functions. Chapter 6, exponential and logarithmic functions. And here's a pledge. As always, I expect students to take the exam on their own. That's the bottom line. So here's chapter 5, polynomials and rational functions. So let's start with the first example. The price demand function of a company that manufactures top is given as such. Find the revenue function R of X. As you know, revenue by definition is the number of units times the price. So it would be X times the P of X, because lowercase p of X represents the price, their product. So all you have to do, multiply this one by X, you get minus 5X squared plus 600X. The company's fixed monthly cost is $1,563, and each unit of top costs $10. Write the cost function, C of X, where X represents the number of packets of tops produced. So we are dealing with Y equals mx plus b. In this case, C of X equals mx plus b, where b is the fixed cost and the variable cost is 10. So C of X is 10x plus 1563. Find the profit function. Obviously, profit function, as everybody recalls, is the difference between the revenue and cost. Simply put, revenue minus cost. So this is the revenue, and we are going to distribute the negative sign. We get minus 10x minus 1563. And so these two combine, and the rest of them remain. So we get minus 5x squared plus 590x minus 1563. How many tops must be produced and sold in order to maximize profit? So we're dealing with the optimization. One way to look at the optimization, we should recognize this as a quadratic function. And a quadratic function either opens up or down. It opens down because this is negative. And when it opens down, the maximum occurs at x equals minus b over 2a. That's where the vertex happens. X equals minus b over 2a. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. So in this case, a is minus 5, b is 590, and it opens down as I mentioned. So x equals minus b over 2a means minus 590 over 2 times negative 5. That's 10. Negative and negative cancel each other. 59 would be the answer. What about the maximum profit? You just plug in x amount, which is 59, into the profit function and evaluate it. So P of 59 minus 5 times 59 squared plus 590 times 59 minus 1563. You work it out, it's $15,842. What price must the company charge in order to maximize profit? We go back to the very top. We see the price function. P of x is minus 5x plus 600. So we replace the x with 59, and we end up with 305. So a quick recap, the price function is given, times x gives you the revenue function, and we have the function C of x using y equals mx plus b. In this case, C of x equals 10x is mx plus b. And then the difference between the revenue and profit becomes, the cost becomes the profit function. Profit is a quadratic, and it opens down, and the vertex occurs at x equals minus b over 2a. That's the idea. All right. The polynomial of degree 3 p of x has a root of multiplicity 1 at x equals minus 6 and a root of multiplicity 2 at x equals 4. P of x passes through the point 2 comma 8. Find the formula for P of x in factored form. So please understand, when we have a root at x equals -6, that means we have a factor of x plus 6. And at x equals 4, that means we have a factor of x minus 4. Multiplicity 1 refers to the exponent. So x plus 6 has exponent 1. X minus 4 has exponent, whatever the multiplicity is, 2. And we put an a in front. Okay, so here's the polynomial function. A polynomial function of degree n is in the variable x is a function defined by P of x equals a sub n x to the power n all the way to a sub 0, where each a sub I is a real, a sub n is not equal to 0, and n is a whole number. So this is the definition of a polynomial function, reminding you of that. A sub n is called the leading coefficient. A sub n x to the power of n is called the leading or dominating term. A sub 0 is the constant. P of 0, if you replace the x with 0, everything goes to 0 except the constant. It is equal to a sub 0, which becomes the y-intercept of the function. So that's understanding what's going on here. And now, going back to this, so this is x plus 6 to the power of 1, or we don't have to write it. This is x minus 4 to the power of the multiplicity 2, and we put the a in front. Now, we have everything except a. And because a pair, 2 comma 8 is given, we are going to plug in 2 instead of x and 8 instead of y, or P of 2. So 2 plus 6, 2 minus 4, this is 8, this is minus 2. So I can actually drop the 8. And as you know, this is 4. So I get 4a equals 1. A becomes 1/4. You plug in and you're done. That's how you find the function. So a quick recap: polynomial functions, P of x, are in the form of a sub n x to the power of n all the way to a sub 0. This is the leading coefficient. This is the leading term. And ultimately, this term will give us the shape of the graph. Divide using synthetic division. Express the answer f of x over d of x equals q of x plus r of x over d of x. And this is what we want to do. So first, reminding everybody of division format. Division of a polynomial by x minus k. If the degree n polynomial P of x is divided by x minus k, that means x minus some number. The quotient polynomial Q of x has degree n minus 1. So because we are dividing by x minus k and it has a degree 1, so the degree goes down by 1. That's why it's n minus 1. The remainder r is a constant and may be 0. So we either have a 0 as a remainder. In other words, when we divide it, it doesn't produce any remainder, and therefore it becomes a x minus k becomes a factor of that polynomial, or there is some number. The complete quotient P of x over x minus k, we write it as q of x plus r over x minus k. R is the remainder. Bear in mind, again, this is degree 1, this degree 1, this must be degree 0. In other words, the constant. Okay. For example, if we look at this one, the top is called the dividend. This is the divisor, 3x cubed minus 2x plus 5 over x minus 3. You go through the process. And the answer is 3x cubed plus 9x plus 25. This is the quotient. And this is the remainder, if you will. AD is the remainder. Okay, so we write this is the remainder, this is the divisor. Okay. And so everybody, I hope everybody remembers the general division, okay, known as long division. We are going to look at the synthetic division. The way the synthetic division works out, we just write the coefficients and we have to go from, we have to put this in order. It is in order, that means in descending order. Okay, that means the leading term has to have the highest power. So this is 3, 2. So you put 3 minus 2 1, and negative 4. And then x plus 1, division by x plus 1, that means you put a negative 1 there. If you're dividing by x minus 1, you put positive 1 here. If it's x minus 5, you put 5 here. If it's x plus 5, you put negative 5 here. Now, one thing I want to make a point of, if any term is missing, let's say this wasn't there, this was missing, then you have to have a placeholder with a 0, otherwise it doesn't work. Okay, so what happens, how does the synthetic division works? You just drop the first number as it appears. In this case, is number 3. Then you multiply what you come up with this number. So we're going to multiply by negative 1. We get negative 3. Now we add these two, we get negative 5. Again, with the multiply by negative 1, we get positive 5. Add these two, we get positive 6. Again, multiply by negative 1, negative 6. They add up to negative 10. So if you divide this one by this one, you get 3 minus 5, 6, meaning if the degree is 3, now it goes down by 1, becomes degree 2. So 3 means 3x squared. Minus 5 means minus 5x plus 6. And this is negative 10, by the way. So that means this is the remainder. You can write plus negative 10 divided by x plus 1, or minus 10 over x plus 1. So this is how you write it. And as I mentioned, this one, you could just write minus 10 over x plus 1 is your choice. That is synthetic division, everybody. That is a little bit fast. So consider the function f of x equals 2x minus 8x squared plus 5x plus 3. List all the possible rational zeros of a function. So what is the rational zero theorem? The rational zero theorem says that if we happen to have a rational root, a rational zero, then it has to be in the form of factors of the constant over factors of the leading coefficient. So rational zero indicates factors of a sub 0 over factors of a sub n. Remember, a sub n is the leading coefficient, a sub 0 is the constant. And for that, again, this one is a sub 0 for us. This one is a sub n, more specifically 3. This n comes from the exponent here. So a sub 3. And so factors of 3 over factors of 2. Now, what are factors of 3? Plus minus 1, plus minus 3. What are factors of 2? Plus minus 1, plus minus 2. Okay. Which means you're going to divide this by this one, you get plus minus 1. You're going to divide this one by this one, you get plus minus 3 halves. You're going to divide this one by this one, you get plus minus 1 halves. And as I mentioned over this one, and so you write plus minus 1 half, plus minus 1, plus minus 3 halves, plus minus 3. So this number over this number over this number. So as you can see, 1, 2, 3, 4, there are 8 possibilities. And so the idea is, as far as the methodology, is that you try this function and you plug in these numbers until you hit 0. The moment you hit 0, that means that is a factor. For example, I'm making something up. Let's say I put in 2, okay, and it gives me 0. That means x minus 2 is a factor. Okay, now you have to go through this process if there is no way to factor that. Okay, you have to go through this process. So what I'm going to do, I'm going to quickly, again, you really, and go with the easy ones. Go with plus minus 1 and plus minus 3 first. And then if you need be, you move on to fractions. So I'm not going to go through all of it. Again, you really have to check. Okay, so if we plug in number 3, because we want to find the rational zeros of f. Okay. Here's the remainder theorem. If a polynomial p of x is divided by x minus k, the remainder is equal to p of k. Factor theorem. The polynomial p of x has a factor of x minus k if and only if p of k equal to 0. So having said that, we put the numbers in, and if it results in 0, that becomes x minus k becomes the factor. Again, I'm not going to go through the whole thing. We're going to try number 3, and it becomes 2 times 3 cubed minus 8 times 3 squared plus 5 times 3. And this is 27. Just erase my word. This is 9, and 2 times 27, 54 minus 72 plus 15 plus 3. It ends up being 0. That means 3 is a factor. So we want to find the rational zeros. Now, to find the remaining, okay, we are going to divide by x minus k, which means x minus 3. And with the synthetic division, because x minus k, we go with the synthetic division. We put the 3 here, and then 2 minus it, 5 and 3 here. So the first one simply drops. Then you multiply these two. Okay, so you're going to multiply it by 3, and you put it here, you get 6. You add these two, you get negative 2. Now you multiply it by 3 again, negative 2 times 3, and you put it here, negative 6. They add up to negative 1. You multiply by 3 again, you get minus 3. And of course, as expected, they will give us 0. So there has to give us 0 unless we made a mistake. If that gave us 0 here, so you can go with the remainder theorem, you can go with the synthetic division, and the remainder theorem is the fast theorem. In any event, so we go back here, the degree is 3, so when we go to here, the degree goes down by 1, so to x squared. So this is 2x squared minus 2x minus 1. Now, again, we could have continued with that. By the way, the rational zero says if there is a rational zero, then it has to be somewhere among those, and we got one of them. There may be 2 more rational zeros or may not be, okay? But here's the good thing. When you have a degree 2, you can go by factoring, or the quadratic formula makes no difference because you want to speed up the process. Either way is fine. And so there is no reason to continue with this process of checking the rest of them. And so obviously in this case, A is 2, B is negative 2, C is negative 1. We're going to plug in. So your x is minus b plus minus a squared of b squared minus 4ac. And so this is positive 2. This is 4. Plus 8 is 12. As you know, 12 is 4 times 3. So it's 2 plus minus 2 square root of 3. And this, I can factor the 2 out. And now this 2 goes away, and 4 changes to 2. And that's the answer. And believe it or not, you found all the zeros. 2 of them happen to be real numbers, irrational numbers, if you will. So if we want to write it in factor form, okay, we're going to write x minus whatever this number is, x minus 3, then x minus one of them times x minus the other one. Here's how you write it. F of x is x minus 3, x minus this one, 1 minus square root of 3 over 2, and this one, x minus 1 plus square root of 3 over 2. This is the factored format, everybody. Consider the function f of x equals x to the power 4 plus 2x cubed plus 22x squared plus 50x minus 75. First of all, rational zeros are factors of a sub 0. That means factors of negative 75 over factors of a sub n. A sub n is 1. So basically factors of negative 75. I want you to know that. But in any event, they are asking for f of 1. There's a reason. So we're going to plug in. So we get 1 to the power of 4 plus 2 times 1 cube plus 22 times 1 square plus 50 times 1 minus 75. I hope you can check it and you see you get 0. Which actually means if f of 1 is 0, one of the factors is x minus 1, everybody. I'm going to leave you to evaluate f of minus 3. That means minus 3 to the power of 4. Okay. Plug in. Okay. Minus 3 to the power of 4 plus 2 times minus 3 cubed and the rest of them. It ends up being 0, which means x plus 3 is also a solution. Okay. So we already have 2 solutions. And so if we were to do by the rational zeros, factors of negative 75 over factors of 1, means plus minus 1, plus minus 3, 5, 15, 25, and plus. So that means there are a lot of them that we have to check. So, I mean, it wasn't too bad. We could do that with plus minus 1, plus minus 3, and so on. But that would be the process. As far as technology is concerned, you can graph second calc. You can look at what I have in Canvas for you. 0 or try these numbers one by one. You can use the graphing calculator to try one by one. In any event, so that's the process. And now, if 5i is a 0 of the function, find the remaining zeros of the function f of I. So I want to go over a couple of theorems. Number one, number of zeros theorem. A function defined by a polynomial of degree n has at most n distinct or unique complex zeros. By the way, the multiplicity counts. For example, if the multiplicity is 2, that is considered true. Okay. And also, conjugate zero theorem, it indicates if P of X is a polynomial with real coefficients, and if R equals A plus BI is a zero of P of X, then the conjugate R bar, sometimes they go with R prime, or they go with the asterisk. A minus BI is also a zero of P of X. So that is called the conjugate zeros theorem. So if that is the case, everybody, and you know 5i is a solution, is a root, so is minus 5i. I want to make sure you know that. I mean, it might be easier if it's, for example, 2 plus 5i, then it means 2 minus 5i. That's the idea. And so putting it in factored format means f of x is, so this one gives us x minus 1. This gives us x plus 3. And this gives us x minus 5i. This gives us x plus 5. And if you want to multiply them through, I remind you that a plus bi, a minus bi is a squared plus b squared. Therefore, the product of these two is x squared plus 5 squared. That means x squared plus 25. Keep this, and those two. And I'm showing you that because if you want to multiply them out, it's easier to do it in this manner. Find the domain of the function, express your answer in interval notation. Domain, as you recall, in the case of a rational function, you set the denominator equal to 0 and you exclude that. So we have to set x squared minus 2x minus 8 equal to 0. You want two numbers. The product is negative 8 and the sum is negative 2. That means positive 2, negative 4, and x is either negative 2 or 4. Now, these are the problem. These are the numbers that make the denominator 0. Therefore, the domain is every real number except those two. Okay? So in other words, if one way to write the domain and we don't want it, we want an interval notation would be x such that x is not -2 and x is not 4. That's not how we want to write it. We want to write it in an interval format. So -∞ to -2, union -2 to 4, union 4 to infinity, everything takes parentheses. Use the remainder theorem to evaluate this function at x equals to. Simply put, plug into and evaluate it. That's the meaning of it, everybody. So let's replace the x with 2. So 6 times 2 to the power 4 minus 2 cubed minus 15 times 2 squared plus 2 times 2 minus 7. That's all. Plug in, evaluate. So this is 16. So 6 times 16 is minus 8. This is 15 times 4. So minus 15 times 4. This is 4 minus 7. 96 minus 8 minus 60 plus 4 minus 7. It adds up to 25, which of course, you could have done it with the synthetic division. This is a lot faster. And because this number is not 0, that means x minus 2 is not a factor. So if somebody says, okay, prove it is a factor or not, you can evaluate the function at that, and that shows it either way. Show that x plus 2 is a factor of x cubed minus 6x squared minus x plus 30. Find the remaining factors. Use the factors to determine the zeros of the polynomial. Well, one easy way, because we want to do x plus 2, because we want to find the rest of it, ultimately we have to do the synthetic division. But there are really two ways. If we are just interested to show that this is a factor, you plug in minus 2. Why minus 2? Because it's x plus 2. So minus 2 cubed, minus 6 times minus 2 squared, minus 2 plus 30. And I'm going to leave it for you to show that this is equal to 0. They do add up to 0 because this is minus 8. This is 4. And I hope you see they add up to 0. However, because we want to find all the factors, we are going to use the synthetic division. And obviously, we start with the first one. We drop the 1. And then we multiply it by -2. We put it here, it becomes -2 and -6. They add up to -8. Then we multiply these two, becomes 16. And we add them up to positive 15. We multiply by -2, we get -30, and obviously they add up to 0 as expected, which means this polynomial is this x plus 2 times, now this was degree 1, this was degree 3, so this is going to go down to degree 2. So 1x squared, or simply x squared, minus 8x plus 50. And now this, because it can be factored, and you want two numbers, the product is 15, the sum is minus 8, -3 and -5. Basically, you're done. So what it means is that the zeros are -2, +3, +5. So by the factor theorem, the zeros of x cubed minus 6x cubed minus x plus 30 are -2, 3, and 5, or by the synthetic division, either way is fine. How about graphing? Let's graph f of x equals x plus 4 over 2x squared plus 11x plus 12. And of course, there are various steps on that, finding the domain range and so forth. Okay. And so to do that, the very first thing is, if you have a fraction or a rational expression, the first thing is, can I simplify? Is there a common factor between the top and the bottom? Even if this can be factored, but it doesn't have a factor of x plus 4, it can't be simplified. So you can try, and I'm going to show you how easy it is. You say, okay, can I factor this such that it has a x plus 4? Are you with me? So you ask yourself, because the numerator is x plus 4. And so because this number is 2, it has to be 2x. So all you have to do, divide 12 by 4, and then you see that it works out. It may or may not work out. So how do you know it works out? You look at these two and you say, well, their product is 8x. This is 3x. Do they add up to 11x? They do. Therefore, you can drop it and you write it in this fashion. Let me erase my book. Now, this is extremely important because one of the things we want to do later on when we want to look at the asymptotes, what makes the denominator 0, that makes it into a vertical asymptote. However, it has to be in lowest term. In other words, x equals -4 can't be an asymptote. In fact, we write x can't be -4. So as far as the domain is concerned, x can't be -4, x can't be -3/2. We write it in this fashion. I hope by now everybody's okay with this concept. So from -infinity to -4, union -4 to -3/2, union -3/2 to infinity. That is the domain. What about asymptotes? What about holes? If there is a factor in common between the two, then there is a hole. If there is no factor in common, there is no hole. Now, where is the hole at? X can't be -4, and you put it in here. So 1/2 times -4 plus 3. -4 comma -1/5. I can't emphasize this enough, okay? Otherwise, x equals -4 is an equation of a vertical asymptote. So -4, -5, this is 0. So 4 to the left, 1/5. So it's between 0 and 1, just one notch going down, divided by 5. So there's a hole there. Now, so you set this equal to 0, 2x plus 3 equal to 0, x equals -3/2. That's the equation of a vertical asymptote, everybody. So you draw a vertical line, x equals -3/2. Now, as far as horizontal asymptote and oblique asymptote is concerned, I want to remind you how we find it. Given a rational function f of x equals n of x over d of x, this is a sub n x to the power of n all the way to a sub 0. This is b sub m x to the power of all the way to b sub 0. If n is less than m, in other words, the degree of the numerator is less than the degree of the denominator, we have a horizontal asymptote y equals 0. In fact, that's exactly what's happening here. The numerator has a degree 0 because a constant. The denominator has a degree 1, and therefore we have the horizontal asymptote y equal to 0. By the way, you either have horizontal asymptote or oblique asymptote. So in this case, we have the HA, VA short for vertical asymptote, HA horizontal asymptote, oblique asymptote, OA or slant asymptote. If n equals m, then the coefficients take over, a sub n over b sub n. And the reason is very simple. Remember, the concept of asymptote, what happens at the end when we tend infinity? And those terms become nothing compared to the leading terms. So the leading terms take over. N equals n plus 1. If the degree of the top is larger by precisely 1, then you can divide. It gives you a linear function and a remainder. The linear function y equals mx plus b is your oblique asymptote. So this is how you find it. So y equals 0. Just remember the x-axis. X equals 0 is the y-axis. Okay. And so now we want to find the intercepts, reminding you that if you have a fraction, everybody, a fraction is 0 if the top is 0, is undefined if the bottom is 0. Okay. So we want to find the x and y intercept. So we go to this one. X-intercept, y is 0. If you set this one equal to 0, nothing happens because the numerator is a number. Pay attention, the numerator has to involve a variable. If it did, you set equal to 0. But if it's a number, positive, negative, small, large, makes no difference. There's no x-intercept. But for the y-intercept, you set x, for y-intercept, you set x equal to 0. If x is 0, this goes away 1/3. So we have x-intercept none, y-intercept is 0, 1/3. That's very straightforward, everybody. Okay. Now, locate at least one point on each side near the vertical asymptote and sketch the graph. I want to explain this one. Class, if you look at the vertical asymptote and we have one, it cuts the graph into two sub-intervals, to the right and to the left. Normally, you get a function like this, or maybe it crosses the x-axis or not. In this case, we didn't have any x-intercept. It doesn't cross the x-axis, okay? And so you pick up easy numbers. If we pick, for example, -2, okay? So we're talking about to the left of this number. If I put -2 here, I get -4, and 3 is -1. 1 over -1 is -1. If I put -1 here, I get +1. So those are the pairs. So we are going to graph those two. And this obviously, even if we didn't have this, this one tells us it looks like that, and this one looks like that. There's a hole here. Now again, as always, you have to set the function equal to the horizontal asymptote equals 0. We actually did that. It didn't work there when it didn't have the x-intercept. All right. You want to find the domain and range. Okay, domain, I'm sorry. X minus 3 equal to 0, x equals 3. So basically, x cannot be 3. How do we write that? From -infinity to 3, union to 3 to infinity. We want to find the asymptotes. By the way, there is nothing in common between the top and the bottom, so there is no hole. Okay. A vertical asymptote, you set the denominator equal to 0. So x equals 3. Horizontal asymptote, we don't have any. Why is it that we don't have a horizontal asymptote? Because the degree of the numerator, I hope you realize 1 times 1 and 1 is 2, the degree is 2. So x equals 3, and it's a dash line, by the way. Okay, all asymptotes are dash lines. So let's actually distribute, and we get x squared. 1 and -5 is negative, or -4x, and this 2 is -5. Now, we want to find the oblique asymptote, and that means we're going to divide the top by the bottom, and we're going to go with the synthetic division. 1 minus 4 minus 5, you get the 1 here. Then you multiply it by 3, you put it there. 3 and -4, they add up to -1. You multiply it by 3, you get -3. Add them up, you get -8, which simply put means when you divide this one by this one, you get 1x, or simply x, minus 1, and then -8 over x minus 3. And therefore, this piece, y equals x minus 1, is our oblique asymptote, and there is no hole, as I mentioned. Why there is no hole? Because there is nothing in common between the two, okay? And so there is nothing between the top and the bottom that is in common. Y equals x minus 1, you have a couple of points like 0, -1, and 1, 0, and you graph it. I hope you have no problem graphing this. So what happens really is that here's your vertical asymptote on this side and on that side. You need to figure out what's going on. And so having said that, we are going to find the intercepts. To find the intercept, if x is 0, everybody, if x is 0, this is 0, this is 0, you get -4, 5 over -3, which is 5/3. This is the y-intercept. And for the x-intercept, the numerator is 0. That means this is 0, -1, this is 0, +5. So you have -1, 0, 5, 0, 0, 5/3. So again, I'm reminding you, a fraction is 0 when the top is 0, and it's undefined when the bottom is 0. So x-intercept, you set the top equal to 0, gives you -1, 0, 5, 0. So those are the two, okay? And The y-intercept, as I mentioned, you put 0. You can put it here, but it's easier here. So negative 5 over negative 3 makes it positive 5/3. And it says locate at least 1 point on each side. We really don't have to. We already have a couple of points on the left side. This is your vertical asymptote, one is here. And that's the graph of the rational function.